Thank you very much for having me. So hello, everyone. If you didn't catch my introduction a little while ago, I'm Andrew. I am perhaps most well known for being a Django core developer. I've been doing Django stuff since about 2008, so it's been a while. It kind of scares me when I remember how long it's been. Mostly I've worked on migrations and South, and then I've worked on async and channels in Django. I used to live in London, England. I now live in Denver, Colorado in the US, which is a lot snowier than anywhere else I've lived, but it's still quite nice. But let's talk about async and sync. So one of the things I've been doing kind of over the last couple of years is trying to bring some more async stuff into Python. I actually started doing async work in Python in about 2014 when I looked at the eventlet library and started trying to do like the very early version of WebSockets when it was still changing. I think every month there was a new spec WebSockets that was different. But things have matured since then. And so let's kind of look at the basics of what it works out in Python, and let's then look at what I'm doing in Django and other things in web frameworks to make it easier. So first of all, if you're not familiar, async Python is concurrent execution. Sequential execution is like this. You run things one after the other. It's very simple. You just go straight through. You can't really run things in parallel. When we say concurrent execution, we mean some way of running things in parallel. This could be threads, it could be async, it could be other forms of it, but it just means you can do things at once. And this is kind of what we're trying to do in Python and in Django. Like imagine, for example, a Django view where rather than querying the database for one query and then querying for a second query, you can just run all your queries in parallel and then return them and render the page straight away. In some cases, you can probably get almost like double speed up or even more than double in terms of how much more performance you can get. So let's do a brief history of async in Python because this is kind of fun. So async in Python starts in 1998, which is a lot further ago than I thought it was when I researched this. The threading module, which I'm sure many of you have used, arrives at this point based on Java's one, but also stackless Python, which is what EVE Online is written in, arrives too. And stackless actually introduces the first idea that's a bit like a coroutine. Shortly after that, Twisted arrives. Twisted is the first proper like coroutine reactor-based framework. And Twisted has basically done all of the things I'm going to tell you like over 10 years ago, but I think Python just took a while to wake up to them and make them sort of more friendly and user-friendly. 2005, they changed generators to make them more coroutine friendly. This is where you get a thing called yield from, where basically rather than just having a yield, you can pass things into and out of generator functions. 2006, we get greenlets. That's what powers G-event, for example. Greenlets are a bit different to coroutines. Briefly, greenlets just run whenever and kind of switch randomly, whereas coroutines only switch whenever you do a yield or an await. As it turns out, we write it now. So it's kind of a bit different. G-event, obviously very popular. I used to write a lot of G-event and eventlet and greenlet code. I don't these days, mostly because I don't like the whole way it switches randomly. And G-event specifically does a lot of monkey patching to make like, oh, the socket module is now magically asynchronous. And I'm not a huge fan of that. 2008 brings multiprocessing. This is an alternative to threading that uses multiple Python processes. The problem with threading, if you've ever heard of the GIL or the GIL, the Global Interpreter Lock, that is the problem it tries to overcome here. Python threads, only one thread can run at once. That's kind of the problem with them. Multiprocessing sacrifices memory usage and lets you run more Python processes, but as a result, you can use more cores. And then going a bit faster, 2012 is the start of what becomes Async.io. Guido van Rossum starts Tulip, which is his experimental library for doing coroutines and asynchronous stuff. We have a PEP for it. And then finally in 2014 in Python 3, we get the Async.io module. It's been kind of a long road from the start to here. And I will say async in Python is still a little bit rough around the edges. It improves every release. And as of about 3.7, 3.8, it's pretty good. But there's still a few things we can improve and we're working on them. As for Django's history, I kind of started on Django async stuff back in 2017 when I first released Django Channels 1, which does not use Async.io. It does everything in threads because it was a Python 2 compatible project. 2018 is Django Channels 2, which does use Async.io. 2019 is when I proposed my big async depth for Django, that bring async into Django itself. And then earlier this year, about a month ago, we finally landed proper async view support into Django itself, which I'll talk about a little bit here in a second. So that means the next release of Django actually has full async view support. You can write async views. The ORM doesn't work yet, but I'll show you a bit of how that works. So let's look briefly at async IO. So as I mentioned, it works kind of on this thing called yield from. Like in some ways, async suffers from its history, from its Python 2 history specifically. It was all written, and Tulip was written based on this yield from thing in Python 2, which is kind of nice. Lets you write these generators and lets you have functions nest other functions. But there's a key problem with the way it works. And that problem is you literally cannot tell if a function returns a coroutine. This is a real big problem because basically you can't look at a function and tell if it's synchronous or if it's asynchronous. So I'll show a brief example here. So here are two functions. The top one is an asynchronous Python function. The bottom one is also an asynchronous Python function. There's a fun thing in Python where you are asynchronous not by definition, but if you return a coroutine. And the normal way of doing this is to write async def. That makes Python just return a coroutine by itself. If you use things like TypeScript, it's the same as async function in TypeScript and promises. But you can also just take a coroutine object, like the second function at the bottom here does, and just return that. And that's still a perfectly valid coroutine function. The problem is async IO ships a function called isCoroutine function that tries to let you see if, as the name suggests, the thing you're looking at is a coroutine function, as in it's an async function. It will only work on the top one of these. It does not work on the bottom one. So this is kind of one of the problems we face in Django, is that we can't really tell totally what you're doing, and it's kind of hard to see. So we'll see how that affects things in a second. The other thing is you also can't have one function that is both synchronous and asynchronous. Because of the way the asynchronous functions work, because they have to run and return a coroutine, you can't actually tell what a function is until it's finished running, which means you can't have a function that is synchronous and asynchronous at once. And so we end up doing things like this. So this is not yet in Django, but this is how we'll have to do it. So what you would want to do is you would want to have Django work like this, where you can have your standard normal synchronous call, like at the top, which is getting a model by ID. That should keep working. What I'd love to do is make the second one work, which is if you do that get call and await it, then we do it asynchronously. But we literally can't tell because both of these calls run the get function before the actual asynchronous stuff comes in. And so unfortunately, we can't do this. We have to instead take all our async stuff and namespace it off into a separate place like this. And so unfortunately, in Django, anything that has to be a separate async callable has to be in this like weird async namespace. We're not sure what we're going to call it yet. We can't call it .async because it's a reserved word. This is just an example. But the idea here is basically that we just can't do it the nice way. And that annoys me, but as you'll see, we've kind of made it more reasonable when we go forwards. The third and final problem with Python async, and I'm talking a lot of problems here. I know there are good things too. There are completely different libraries. This is kind of a follow-on from what I just showed you about you can't have the same function be synchronous and asynchronous. You kind of can't have the same library be synchronous and asynchronous. You can, but it means writing two whole separate parts of the library. And so, you know, as a start, like you can't even use the time.sleep command. That's now a new thing. But like requests, you replace the HTTPX. PsychoPG2 has a replacement. WSGI, we had to replace WSGI because it was different. All of these different things have to have replacements. And the thing I want to avoid with Django is having a replacement Django, because I don't want to have Django and async Django, because maintaining two Djangos is a nightmare. And I just don't want that kind of work. And so what we've tried to do is keep Django have it be one thing and have it have asynchronous and synchronous in the same project. That is kind of difficult, as I'll show you here in a second. The one thing to consider, the reason this works in Django is that async support is only really sensible for code that is input-output bound. Basically, if your code just sits there and runs very CPU-intensive stuff, there's no point making it async whatsoever. But if all it does is network calls, then it's very important to make it async. So for this reason, things like templating, we don't really need to make them async that soon because they're mostly CPU bound. Whereas things like the ORM are mostly doing database calls over the network, and that's going to benefit a lot from async. So we're adding async to some parts of Django, kind of the bits where it makes sense. And I'm going to go through now and show you like what those main parts are in the request flow and what we've done so far. So here is a very simple diagram of the rough flow of how Django runs requests internally. When you run Django, it sits underneath a WSGI server or WSGI server. You can see that right here. And then basically as it runs, the WSGI server calls a handler, which is basically a callable object in WSGI. And then the handler sort of decodes the request, turns it into the Django request object, and does some of that basic work and understanding of what's going on. Once it's decoded it into a request object and like done like upload parsing and looked at what you're putting in the post requests, it then passes it into Django proper. And then we have a thing called the base handler. And the base handler is what essentially takes the request, works out what view it does via the routing, runs the middleware, and then finally hands it off to the view to finish calling it. And that's kind of the way that synchronous Django works. And what I wanted to do was I wanted to basically have something that was as close to that as possible and not duplicate it where I had to do. So my first plan, which I proposed sometime last year at DjangoCon, was this. I wanted to have parallel things for ASGI. So you see here, ASGI and WSGI are different. The reason here is WSGI forces you to be synchronous. We had to invent a asynchronous version of it, which is ASGI. Support is already in a couple of more frameworks other than Django. I know Flask are also looking at it, but it's a bit more tricky for them because of the Flask is very heavily based on WSGI, whereas Django is a bit more loose, which is handy for us. And then we have separate code paths for the request handling, but the idea was to have the same code path to handle that sort of decoding of like, what are you doing? What's the URL routing? And how do we run the middleware? Unfortunately, I got this working, but it was way, way too slow. Because the problem is every time you change from the async world, which you see here in red at the bottom, to the synchronous world, which is in blue at the top, these calls across here, they take time. They only take 1 or 2 milliseconds, but the problem is we didn't want to make normal synchronous Django slower. Like I finished this, it was working fine, it passed all the tests, but it made Django about twice as slow for normal synchronous calls when it was just doing nothing. And so we had to go back to the drawing board and rework out what to do, because I am not willing to ship a version of Django that is slower by default. That's not what we're here for. And so the new version is this, which, as you can see, has a lot more duplication. We've had to basically take a second version of base handler down here that runs asynchronously. But the nice thing is this runs with 0 performance penalty whatsoever. If you run synchronous Django, notice that your request never ever goes into the asynchronous world. It always stays up here in the synchronous land. That means that synchronous versions of Django run as fast as they always did. And then asynchronous Django, if you want to, runs purely asynchronously, or if you want to, you can switch between them. So what the nice thing here is you can write synchronous views and then you can call them from asynchronous Django. And vice versa, you can write asynchronous views and they'll run perfectly fine underneath the synchronous Django. Now, doing this second one, there is a performance penalty. You won't get all the benefits of async, but you can still do things like parallel calls. And so basically, we've tried to keep Django quick. There is some duplication. One of the nice things was when I looked into the handler code, it hadn't been touched in about 10 years. And so I did a decent amount of refactoring and pulled a lot of the shared pieces between these two out. And so now a lot of that code actually is all shared anyway. And it's just like a top level function that happens to be the different version between sync and async. The last thing to mention here is middleware. Middleware does basically in Django, it wraps around the view now. So when you call a view, you sort of wrap it in layers of middleware and call through them. That way, if you have an exception, the exception bubbles up out through the middleware and you get a chance to catch it. Now that's great. The problem is that if you are asynchronous, you don't want to have to basically go through here and then jump to a synchronous middleware, because as soon as you do that, you have to spend a whole thread running that synchronous code, because you basically left asynchronous land, which makes it inefficient. And so what Django will do is Django will basically try and take your middleware and wrap it in an asynchronous layer and then keep going. This doesn't work for all middleware, and there's lots of docs on how to do this if you write very complex middleware. But if you write basic middleware that uses middleware mixin, this just happens for you. It's basically automatic. And all the built-in Django middleware as well runs like this. So basically, if you take normal core Django and then you just run it with an async view, it will never ever context switch out to synchronous mode. It will always say async mode. You'll get full support for asynchronous, like waiting and long polling and like all the things you can do that are more efficient with asynchronous Python. I'm going to do a brief look at what it looks like to write this, and then I'll sort of stop and open up the questions. So in Django 3.1, which is coming later this year, you can just do this. You can write a asynchronous view by just writing async def on your view. Django will detect that it's an asynchronous function. It will just call it asynchronously, and you can do whatever you like in the middle that's asynchronous. And then as long as you return a response, it's all fine. There's even extra error detections. If you return a coroutine wrongly, Django will pick it up and warn you rather than failing silently. We just try to make it more safe and easier to use in sort of the Django way than it could be otherwise. As well as views, as I said, you can write async middleware. You can also write middleware that is both. So if you've got a very complex middleware, Django will tell you when it starts your middleware which mode you have to be in, and then you can adapt to be that particular one if you've got like very complex things you want to make efficient. We have async tests. If you just start a test method with async def rather than def, it will just run asynchronously. I'll not say it's magic, but it is looking at the function and running it in an async loop. And then finally, there's an async test client as well. And so all the basic tools you need to write asynchronous views and like run handling is in Django 3.1. The one thing that's not in there is an asynchronous ORM. The ORM is over half the code in Django, and so it's a bit more of a big problem to tackle. So we have to do this one first, because there's no point having an async ORM if you can't call it from anywhere. But now I've got this, my next task is to go and get some other people, work on the ORM. Hopefully by Django 3.2 we'll have something, but I'm not going to promise anything here. But basically that's kind of the next boundary. And then once we've got that, we're mostly done in terms of the key parts of Django that have to be asynchronous. Things like forms and template rendering probably don't have to be. They're mostly CPU bound anyway. But we make things like the cache framework, we probably will add it in later. But essentially, the key thing we wanted to do was make it so that you could run async views. Because what this means is, if your website is mostly, say, API calls, you can take Django 3.1, you can take HTTPX, which is that request replacement that's async, and just do all your API calls in parallel. And that will probably save you seconds of runtime. You could probably return your function in a third the time it takes normally to return. And to me, that's what I wanted to get into Django 3.1 and what made it so important. One quick last thing here. People often ask, like, well, why should I use Django? What's the point of Django? I love other Python frameworks too. And this is more dig at non-Python is other Python frameworks. But like Django's main job is safety. Like when I write Django stuff, the thing I'm trying to do is make sure that A, when you are upgrading, nothing will break. And it's fully backwards compatible. And as you saw, that it runs the same speed or faster. And that B, if you sort of screw up, if you make a mistake, it's not going to hurt you too much. This is why like Django tries really hard, for example, to stop you leaking passwords. It like hashes them out in the debug view. In the case of async, we try really hard to take all the sharp corners of asynchronous code and smooth them down. Like if you forget to return a coroutine properly, if you leave a dangling coroutine somewhere, Django will usually try and detect it and warn you about these things. There are some things we can't do. Python kind of has an issue with async usability. Part of this is like, I think I need to go to Python core and start asking for a little bit more, either in documentation or in keywords. I would love to solve the problem of not having one function be both synchronous and asynchronous, but I've talked to several Python core devs and that seems almost insurmountable or unsolvable. So we'll see. But we're getting there. And I think my goal is having Django be a much more usable, easy entry point into asynchronous code. And more importantly, letting you do a Django project where most of the project is normal synchronous Django, and then these two views are asynchronous. To me, that makes it much better because you can take asynchronous code and use it just where you need to. It's too complex to use everywhere in many cases, but if you can use it just where you want to, like at work, there's a few things where, like, well, that specific thing you want to make asynchronous because you're doing a lot of network calls. That works really well for me. Finally, a quick look at the future. There is a lot of speculation on what we can do with Python async. There is a chance we can remove the global interpreter lock, the GIL, and async can help do that. I'm not going to hold my breath, but I am cautiously optimistic that this will happen. And hopefully that will then give us an even faster Python, and async will become an even better way to run code in parallel. Compared to threading especially, it's much easier to reason about async applications because you know that once you start running an async function, it cannot give up control until it hits an await. And to me, that just helps over threading or G-event or other things like that. So I'm going to end here, and I'm happy to take questions. I'm sure we have a little time. But thank you very much for having a little talk from me, and I hope you learned something.
Thank you so much, Andrew. Virtual applause.
Yeah, virtual applause, yay!
And I do have some questions to get us started. If anybody else has a question, feel free to ask openly after I'm finished, or ask on Slack and chat, and somebody will read it out. You don't have to if you don't want to. So my question would be, where do you see the major benefits outside of the obvious? Like you talked about some of the obvious use cases, like calling an API, etc. Do you think that this would help even like the regular plain or boring CRUD application using the ORM once that becomes asynchronous?
Yeah, so like I think with the ORM specifically, like my plan there is like, can we design a slight improvement to the way you call the ORM where you don't have to do things in parallel manually, but we can do them ourselves. So one example is prefetch related, where if you do multiple prefetch relateds, Django knows it can run those in parallel because we know they're not connected to each other. And like, part of me is wondering, like, can we add a few more tweaks to the ORM, the query style, where we can do a lot of this for you, where you can ask for, I want these 3 queries run in parallel, and then Django will work out the best way of doing it, kind of like a query planner, but one level up. So that's kind of what I hope for. And then again, things like Django REST Framework and other plugins, my hope is that a lot of those abstraction layers can use these kind of concepts to just make your site faster. At the end of the day, like what I want is to make Django sites much, much faster. Like my kind of secret goal is to make Python the easiest asynchronous thing, like language there is, and basically have everyone go like, oh wow, like, I know Django and Python have been around for a while, but it turns out they've really improved, and it's the safest, easiest way to write asynchronous code. And like, I can just sit down and in 10 minutes write a fully asynchronous web backend for my like Vue or Angular frontend.
Thank you. Alex has a question.
Yeah, you a little bit touched that with the last response. Like, do you know if there are any Django reusable applications, or like some framework like Django REST framework or others that are building on top of Django that are adopting async view or like Django async calls, or that they have plans to do so?
So, I mean, it's not released yet, which is probably preventing a lot of people from doing it. I've heard some people discuss they're going to think about it. Django REST framework is one exception in a way. So Tom Christie, who is the original author of Django REST framework, he has basically launched a new project called API Star. It is not based on Django, but it is based on ASGI, which is the protocol that basically I and some others invented to run underneath this. And one of the nice things about ASGI versus WSGI is that it is much more intercompatible between applications. And so my hope is that you'll be able to just mount an API star project into Django and it will just work. There's also other things like Dataset, which is someone else's project, has ASGI support. Like ASGI is kind of where it's at right now because we've got that specification matured and it's published and it's stable. I think once we see Django 3.1 release, we'll see a lot of quick improvement from third-party apps. Like certainly, I've talked to several maintainers who were like, yes, when it's there, we'll do it. The main problem is that we landed this in Django 3.1 right as the pandemic started. So everyone's a bit busy right now. But hopefully when we all get a bit more time, we get somewhat back to normal, we'll have time to improve it and do some of that stuff with third-party apps too.
Thank you. Anybody else with a question? Yes, Ash?
So one of the things that I always liked about Django is it was relatively easy to debug. And my experience with Python async is it's not easy to debug.
That is an accurate experience.
Is there anything out there, or is Django looking into ways of improving how it handles debugging and exceptions that are not thrown unless you do something extra and stuff like that?
Yeah. So exceptions. So like I ran this a lot, as you can imagine. Async debugging is basically the bane of my life for the last 3 years. There are a couple of things Django does to make it a lot better. The first one is exception and like deadlock handling is massively improved. So when Django changes between synchronous and asynchronous land, it doesn't use the Python built-ins because they don't do this very well. And we have our own versions called async to sync and sync to async. Let's see if I pull those up actually here briefly. GitHub.com, Django, ASCII ref, here we go. So we have this module called ASCII ref, which is kind of the basic, like here are useful things for asynchronous web frameworks in general. And in this module called sync, there are these things called async to sync, which is this one. And then down here, there is a sync to async as well, which I'm not going to find. There it is. These basically are very intelligent things that switch between the two worlds. They do things like they make thread locals work properly. They make context files work properly. They propagate exceptions correctly. And they make sure that if you run things in synchronous mode, they all run in the same thread. That last one is terrifying. Don't look at the code for that. But essentially, like it makes a lot of that process a lot easier. There's still weird stuff for sure. Like there's still cases where like, oh, I've raised an exception and the traceback looks ridiculous. We need to start working on fixing those as well. We probably have to start looking at like editing the traceback objects, which I'm not a huge fan of. But in general, like it is better than default Python already. And my intention is like, as we see feedback, as we work out what the common problems are, we're going to put like checks for all those things directly into Django itself. There even is a couple of like system level checks in Django. Like when you run Django checks in 3.1, it will do a couple of async checks too to make sure your setup looks all right as well. So not perfect, but we're trying to get there. Thank you.
Great. Anybody else with a question? I see Vatsal has his hand up.
I wanted to ask about the thing you already mentioned, like these double versions of each library. Like for Postgres, you need two libraries. If you start supporting this async ORM, do you need to have two libraries? And do you expect that this async features in Django will lead to improvement in these areas in Python? Yeah,
so I mean, there's two parts to that, right? So the first part is I do think Django will have to use two different libraries. Django at least has a long history of like we have 5 different database backends already. We do plan to also wrap the existing database libraries in threads if we need to. So if you are running asynchronous Django, but you are running PsychoPG2, we will at least like, you can use the async interface, the ORM, and it will run them in parallel threads in a way that gets you most of the benefits. But also we will have to invent a new like database backend specification for async ones too. So our intention is basically, initially the ORM will be async on the front, like the querying will be async, the back will be a thread pool, but that'll get you most of the benefits. And crucially, we can give you the async API up front, and then we can work to optimize it and make it faster without changing the API as well afterwards. As for, what's the second part of the question? I've forgotten now already. Sorry.
The question was that having async support in such a major framework as Django is,
yes,
do you think it will help with like getting this like schisma in the libraries?
Yeah.
solved up?
That's definitely my intention. I've always seen like Django is a very useful force for good if we do it right. And I think one of the things here, like one of the reasons that ASGI has become a semi-standard, like Python core were like, we don't want to have a WSGI replacement. They basically said no. So I went, okay, we'll just go and put it in Django then. And like between that and Tom Christie's work, we've got a lot of traction because I think having a visible example of it working helps a lot. My hope is the same thing is true of like database backends. For example, Python has a DB API 2, which is how we talk to data drivers. There is no async version of that. We are probably going to have to work with the current async database people to try and invent one if we can. But there are things like that. I think like having Django, and then also like I'm trying to rally, and we've been pretty successful. There's like other frameworks and other parts of Python too. Like a lot of different people have these same problems. And I think like collaborating is just a way of doing this. So yeah, my hope is we can make all this much better, that we can fix some of the core issues in Python async as well with a bit of pressure, but yeah, and then make these libraries much better supported. For the record, the Postgres libraries, there's actually a better one than AIOPG. They're very good already. Like they're basically great. So like there's not really a need for any improvement there. MySQL is a little bit more sketchy, and then let's not talk about Oracle because, but basically, I think we can help. I think you're right, and my intention has always been to use Django to push both Django forward, but also Python as a whole forward as well.
Thank you. So we have a follow-up question, which I assume you just answered, but that was, will any of this get into Python, or is that any of your intention? So anything you would add?
It's an open dialogue. I think it's the polite way of doing that. Python core, only a small number of Python core actually work on async, and so their time is quite valuable. It's hard to get this stuff through. At the same time, like there's been some good discussions there. I think especially the sync to async stuff in ASCII ref is prime for moving over. In fact, in Python 3.8, there is now an async io.run that is almost as good as async to sync. It just doesn't do thread locals. So my hope is we can get some of that stuff working and make it better. But at the same time, I think Django has always been kind of separate, and the web programming as part of the bigger Python ecosystem has always been like, it's a slice. It's not everything. I don't think scientific Python cares yet much about async. I'd love to help make it useful there and make it run things faster. And that's kind of my end goal, is like, how can we help all of Python like benefit from async? But at this initial point, like we're still finding our footing. We're still trying to work out how to do it best for web. Like the Flask folks are still trying to figure out how to make their stuff work best with async. I think once we've got a lot of those things figured out, we can take those same patterns and like use them elsewhere.
Cool. And we have last question. There is this weird obscure tool called Django Channels. You might have heard about it. Is that going to be folded in? What are the plans there now that Django itself is async? Is there a convergence in our future?
Yeah, it kind of, right? So Django Channels, its main purpose is WebSockets. And I think I don't want to put WebSockets itself into core Django, mostly because they're a very different way of writing web code, and not a lot of people need them. That said, a lot of channels is the same as Django. Like all the request stuff I showed you, that's all duplicated basically. So I suspect we'll get to a channels 3 that is basically a very thin layer that is just the WebSocket parsing, and the rest of it just uses Django async. And so we can probably delete like 75% of the code in channels as a result of this, which is certainly the plan once I get round to helping Carlton out with it. But yeah, like we're not going to fold WebSockets in, at least not in the next release. I just think WebSockets are a bit like they're very easy to shoot yourself in the foot, as it were. But I do want to make it much more tightly integrated and use a lot of the Django stuff. Like it would literally just be like the protocol parser for WebSockets, and then maybe the channel layer stuff, and that'll be it.
Cool, thank you. And I see no other questions, so I'll ask the last one. So if you were allowed to go completely crazy and there were very few objections, like how far do you think this would be taken? Like, for example, from my side, I would love like template tags to be able to render in parallel and asynchronous if they do different things, to kind of move more towards the edge side include model of building stuff. What would be your crazy dream?
Yeah, I think my crazy dream is that we get Python to adopt a separate _a call method so we can do all this. Like that will take a huge overhaul to the way the language runs in a weird way. But I want that too. Like, I want the world where you can just have synchronous, asynchronous code coexist, and Python just flips between them at will, and it runs whatever the best thing is for your current situation. A bit like MyPy, right? Like MyPy is typing when you want it, and and when you don't want it, you can just ignore it. I want the same thing for async. And so like my dream is that we just like, you can just load up Django or any other framework. You can write whatever you want, and you go, oh, this one function should be asynchronous, and wrap that one function, and it all just works. I think that's the dream. We're still a ways off of it, but I think we've got a lot closer in the last couple of years than we were. So hopefully we'll get there.
Awesome. Thank you so much for coming here. I know that
Thank
it's
you for
early in the
having me.
morning, so we appreciate it.
Yeah, no, thank you all. I got to get back to work, but it was a pleasure speaking to all of you. And hopefully I will see some of you in person soonish. But have a lovely evening.
Thank you.
Yeah.